Hey guys, so we're going to continue with logarithms. Now we're going to talk about logarithmic equations. Alright, so just to review, we have three properties of logarithms. Remember, the first one is product, our product property. Okay, just means when we have multiplication, we can expand using addition. Right, the next one is a quotient property. Alright, and that means when we have division in our logarithm, we can expand using subtraction. And our last property is the power property. Right, when we think of power, we think of exponents. Okay, so I have log base b of m to the power of n. And if you remember, the exponent comes out front in front of the logarithm when we are expanding. Okay, so for most logarithmic equations, there are three steps to follow. Step one is to isolate the logarithmic expression. So isolate the log. Step two, rewrite in exponential form. Step three, solve for the variable. Okay, so most of the time we can follow these three steps. Alright, let's look at some examples. Example 1. Okay, so for this example, step 1, if you remember, was to isolate the logarithm. Okay, this is the logarithm right here, log of x plus 4. This 3 is multiplied to it. So in order to isolate it, we need to divide both sides by 3. Alright, then we're going to get log of x plus 4 equals 2. Okay, and the next step says to rewrite in exponential form. Okay, in order to do that, we need to remember that the base here is 10. If there's nothing written there, it's understood to be 10. So remember, when I'm rewriting in exponential form, it's my base, 10, my exponent, 2, and then my answer, x plus 4. This is the exponential form of log x plus 4 equals 2. Right, and then we can solve this for x. 10 squared is 100. Subtract 4 from both sides. X equals 96. Remember, guys, to rewind, pause the video as much as you need to. Alright, let's look at another example. Oops, that's not what I meant to write. Alright, so ln is a logarithm. Okay, this logarithm is the natural logarithm. And that's an ln, not an in. I know you guys, a lot of you like to think that that's an I, but it's an L. ln of x. Okay, ln is the same thing as log base e. Right, e is a number just like pi. Okay, the pi is 3.14 blah blah blah. E is also a number. Okay, so step 1 was to isolate the logarithm. Okay, the logarithm's already isolated and we have ln of x. Okay, step 2, rewrite in logarithmic form. So if I rewrite this, my base is e, my exponent is 4, and then my answer. Okay, so e to the power 4. If you look at your calculators, e is found by pushing second and then ln, second ln, and it'll give you e and then a box up here, or the up arrow to give you an exponent. So you just put e to the power 4 in your calculator, and it's about 54.6. Alright, so this example we have log base 5 of x plus 1 equals 2. Our logarithm is already isolated, so we can move on to step 2. Step 2, rewrite in exponential form. This is my base, my exponent, my answer. Okay, 5 squared is 25. And now I can just solve it for x. Subtract 1 from both sides. X equals 24. Alright, now let's look at some examples where we have to use our properties to solve it. Okay, so in this example, we have two logarithms on this side of the equation. Okay, we have log base 9 of x plus log base 9 of x minus 8. Both of these logarithms have the same base of 9. Okay, that means that I can condense them into one logarithm. Since this side has addition, expanding it, I can condense it using the product property or using multiplication. So this changes to, since it's addition, I use multiplication, log base 9 of x times x minus 8 equals 1. Okay, see how I went from addition here, and I had 2 logarithms, I went to only 1 logarithm, and I used multiplication. Okay. Now that I've done step 1, so step 1 was isolating the logarithmic expression. That included condensing this. So now I can rewrite it in exponential form. So my base 9, my exponent 1 equals x times x minus 8. 9 to the power 1 is just 9. Distribute here. X times x is x squared. X times negative 8 is negative 8x. Right? Now I have to solve for my variable. Anytime I see x squared or a variable squared, and then I see 2 other terms, that tells me that I have a quadratic equation. So I'm going to move my 9 over by subtracting 9 from both sides. So I'm going to get x squared minus 8x minus 9 equals 0. Okay, so you guys need to remember how to solve quadratic equations. Right? If you don't know how to factor by this point, by being in, you need to go back and practice factoring. Okay, so 2 sets of parentheses, put an x in both. What are the factors of negative 9? Then when I add them together, give me negative 8. Okay, and those are negative 9 and positive 1. Okay, when I solve those, I get x equals 9 and x equals negative 1. However, my answer to this problem is x equals 9, because if I plug negative 1 back in up here, I'm going to get 2 negative logarithms, and you cannot take the logarithm of a negative number. So my answer is just x equals 9. Okay, so that's something you need to remember. So star it if you have to. Okay, the log of a negative value is not a real number. Right? So your answer x can be a negative number. However, when you plug the value in for x, if it's still negative, like up here, if I plug in negative 1, I'm still taking the log of a negative, so that can't be the answer. Okay. Alright, let's look at another example. Number 5. So this time we have 2 logarithms on this side of the equation and 1 on this side. It's okay to have 1 logarithm on each side of the equation, right? But you can only have 1. So again, we need to condense this side, and again, we're going to use the product property with multiplication. So this side is going to condense down to ln of 2x minus 3 times x plus 4 equals ln of 2x squared plus 11. Okay? Whenever you have two logarithms, one on each side, the logarithms just drop as long as they have the same base. And these are both natural logarithms, so they do have the same base. So they go away, and you just set what's in parentheses equal to each other. Okay, now we're going to FOIL these two together. Remember, FOIL first, outer, inner, last. So 2x times x gives me 2x squared. 2x times 4 gives me 8x. Negative 3 times x gives me negative 3x. Negative 3 times 4 gives me negative 12. Bring down the other side. Okay, combine your like terms. 2x squared plus 5x minus 12. Okay, both sides have 2x squared. You know, they cancel. Okay, sorry about that, guys. So the 2x squares cancel. You're left with 5x minus 12 equals 11. Add 12 to both sides. Get 5x equals 23. So x equals 23 over 5. Okay. Let's look at another example real quick. Just because I don't think I've covered an example like this. Alright, so we have log x equals log 1 minus x. And again, like I said on the previous example, if we have one logarithm on both sides of the equation, and they have the same base, in this example they have base 10, the logarithms just cancel. So we have x equals 1 minus x. Okay, add x to both sides. 2x equals 1. Divide by 2. X equals 1/2. Alright. Okay, one last example. Alright, in this example we have log base 4 of 48 minus log base 4 of x equals log base 4 of 6. Okay, so we have more than one logarithm on this side, so we need to condense. We're going to condense using the quotient property because we have subtraction. So we'll change this to log base 4 of 48 over x. equals log base 4 of 6. Right? Now I have one logarithm on both sides of the equation, and they both have the same base. They have base 4, so they cancel, and I'm just left with 48 over x equals 6. My variable is on the bottom of my equation, of my fraction, so I'm going to multiply both sides by x. Oh. So they cancel, and I'm left with 48 equals 6x. Divide both sides by 6. Alright, so x equals 8. Alright, all done.